Hello everyone, today we'll be going over the three file system implementation techniques, which are contiguous, linked, and indexed. So starting with contiguous allocation, contiguous allocation is a very common technique where each file occupies a set of blocks on the disk. In simple terms, it's a technique where each singular file takes up a set of blocks that will always be next to each other. You can tell by looking at the word contiguous. According to Google, contiguous means next or together in sequence. Apply that to data blocks and you can tell that contiguous is when data blocks for a singular file are always next or together in sequence. Over here, we can have a look at this diagram that represents this technique. So if we look at the file named count, we can see that it has a length of 2 blocks and it starts at block 0. The 2 blocks are in sequence, right next to each other. In fact, that is what you'll notice with all the files. The other files, list and tr, both have all data blocks in sequence right next to each other, as that is what the technique essentially is. Contiguous supports both random and sequential access, so I'll quickly show you an example of how random access works in this case. If a user, for example, wants to access the second record of the list file, then the operating system checks the starting point of the file as the first step, which is 3, and adds 1. This tells the operating system the second record of the list file, which starts as 3, is block 4. Now, the reason that it added 1 in this case is because I wanted to access the second record. Since the operating system starts counting at 0, 0 plus 2 equals 1. So, if you don't understand that, I'll just do a small explanation. So, because operating systems start at 0, adding or looking for the second record would be number 1. And the reason that is because we start at 0, so 0, 1, 2. Now, the second one in that count would be 1. See, 0, 1. So 1 would be the second record. So they do 3 plus 1 to find the second record in the list file. Now, this technique does have a few disadvantages. First off, we run into an issue of finding space for new files. If I quickly go back to this diagram, you can notice a pattern occurring here. So if you have a look at these blocks, you will see that they've found enough space and they've been allocated data blocks. But the issue is now we've got this 2 sitting over there on its own, 6 and 7 sitting there on its own. And yes, if we have files that are 2 blocks big or 1 block big, we'll be completely fine. But what happens if we have files that require 3 to 4 blocks? Then we have an issue where, yes, we might have enough space for that file, but because we're using contiguous allocation technique, it won't allow us to allocate all the space, as those 3 blocks aren't contiguous with each other. Now, the second disadvantage we run into is simply external fragmentation, which is essentially what we explained above, and it's when the total memory space is enough to satisfy a request, but it is not contiguous, which we know means in sequence, therefore we can't use it. The next method, which I'll open up here, is called linked allocation. In this file system implementation technique, each file is a linked list of data blocks. Now what that means is that all data blocks are linked to each other. They do not have to be contiguous, which means in sequence or next to each other, but instead can be scattered around. Now due to them being linked, it does not matter where they are placed, and you might have noticed that this solves the problem of contiguous allocation in terms of external fragmentation and finding space for blocks, and finding space as blocks can be scattered anywhere as they are all linked. Here you can see a great example of what linked allocation looks like. The file essentially has a starting point and an ending point, which in our case is 3 and 6, and as you can see, the order and placing of the blocks do not matter as they are all linked to each other. For the computer to remember what comes after the starting block, a small amount of space is set aside in each block to point to the next, and in some cases, to point to the previous one as well. Lastly, it does come with one major disadvantage, and it's only for sequential access. There is no way to use linked allocation and random access. And that's where indexed allocation comes in. Now this is the last technique for allocation. It is known as index allocation. In this technique, all the pointers to the other blocks are stored in a single block. This is much better explained using a diagram. In our case, we will again use the list file, and list starts at block 3 in the indexed allocation technique. That would mean that the starting block is the block that holds all the pointer information. So if we go to block 3, we can see here it holds 4 pointers. These pointers are telling the operating systems that the data blocks that occupy the files are in those locations. The first data block for the list file is 0, then 4, then 6, and so on. As you see below, I have written the steps the OS takes to access the block. First, it goes to the index blocks and finds all the pointers, and second, it goes to the pointed locations to access the blocks. Now, this solves the issue of external fragmentation, and this is because it's supporting direct access to the blocks occupied by the file. And on top of that, it doesn't matter where the blocks are placed because we have pointers that point to the location of the blocks. Therefore, every single data block is going to be utilized, and external fragmentation and the free space issue is going to be completely wiped away. The one issue that it does come with, which is quite noticeable, is pointer space. So, to put this simply, if a file only occupies 1 or 2 data blocks, then the pointer index will have to take up a whole third block just to save the location of the data blocks. That means with this method, you will, for example, use 2 blocks for a 1 block file, because 1 block will be data, and 1 block will be used for the pointer. So, that was the 3 file system allocation techniques commonly used today. Let me just close this quick. I hope I was able to help you all in better understanding this topic. If you have any questions, feel free to comment them. I'll try my best to answer it. Thank you for watching, and everyone have a good rest of your day.